Hello all. In the last video we have discussed how to delete an element at the end of a linked list. Now in this video we're going to see how to insert an element at a particular position of a linked list. Let's understand that first. We're going to discuss how to insert at position. We have already seen how to insert at the start of a linked list, how to insert at the end of a linked list. Now in this we're going to see how to insert at particular position. So let me take a linked list 10, 20, 30, 40. There is my linked list. Now I want to insert a new element 50 at a position 3. Here what is position? So I'll take positions as 1, 2, 3, 4. These are not indices, they are positions, just natural numbers. So I want to insert 50 at third position. It means here. Here I want to insert 50. So if I insert this, my linked list will be like this. So this will be my third element, this will be fourth, this will be fifth. This is how we insert an element at a particular position. Now let's understand this. Okay, let me take a linked list again. 10, 20, 30, 40. This is pointing to null. And this is my head node. Done. Now I want to insert a new node 50. So in order to insert this new node, this will be pointing to null initially. At position 3, I want to insert this at position 3. Let me write the positions. It will be 1, 2, 3, 4. I want to insert it position 3. Now let us see. So at position 3 means here, right? It is here. How can I do that? Can I say if this is my third element, if 50 is my third element, what will be my linked list look like? It will be like this, right? This will be pointing to this and this will be pointing to this, right? Instead of 20 pointing to 30, this node, the node containing 20 will be pointing to 50 and the node containing 50 will be pointing to 30 if this was a third node, right? So now we have to do the same. We have to make this node point to the new node and make the new node point to the next node. Then we have just inserted this at the third position, right? Now okay, let me write the flow for this. So if we see, I have to reach this position, right? What is that position? First I have to traverse till where my position where I want to insert is 3, but I have to traverse till this position. Why? Because I have to make this point to the new node, right? So I have to traverse till the given position. The given position I'll call it as P minus 1. P minus 1. P minus 1 in this case is 3 minus 1, that is 2, right? So I have to traverse till P minus 1 node. Done. Next, step 2. I have to make my P minus 1 node. I have to make my P minus 1 node point to new node. Point to new node, right? I have to make this point to new node. But before making this point to new node, we have to do one more thing. First, we have to make this new node point to this. Okay, I'll write over here. Let me clear this. Okay, this need to be third step. This need to be third step. So the second step is I have to make my new node point to this node. What is this? This is this node dot next, right? P minus 1 node. P minus 1 node is this node dot next. I have to make this point to this. That is P minus 1 dot next. Done. And last, you have to make this P minus 1 point to new node. These are the three simple steps. Now let me write the code for this over here. So first what we'll do is we have to traverse. So in order to traverse, we need to take a current pointer, right? I'll say my current pointer is equal to head. Done. My current pointer is head. Now I'll take a while loop because we are traversing. I'll write the condition later on. So traversing means my current will be current dot next. This is the logic for traversing, right? Now here I want to stop traversing when I reach the P minus 1. P is the given position where we have to insert the node. I have to stop my traversal when I reach the P minus 1 node. So for that, what I'll do is I'll take current, I'll call it as current position. I'll take current position as 1. I'll take one more pointer. Initially, the position, this is just to track the position of our node. That is the number, that is the position. So initially the value of this will be 1 because my current position will be at the head node, which is the first node. So that will be 1. Done. What I'll do is I'll keep on incrementing because my position is moving, right? If my current pointer is moving, I have to change the position also, right? So I'll say my current position plus plus. My current position also gets incremented. So what will be the condition over here? So I'll write the condition first. I'll say current position is less than, given position is P. Okay, I'll write in different color. Given position is P, that is current position less than position, given position is P minus 1. So why current position less than P minus 1? Now let's see this. Initially my value of current position is 1. It means my current pointer is at this place. So it is 1. Now I did current equal to current dot next. Current equal to current dot next. It means my current pointer will be here. And I will also increment the current position. So the value of position will also be 2. Here it was 1. And my current pointer is also pointing to this node. Now I have to stop here, right? So the value of P is 3 that I want to insert at third position, and here at this point current position value will be 2. So 2 less than 2, condition fails, it will stop, right? So we need to reach this node. That's why we'll say my current position is less than given position minus 1. When this is true, we will traverse, right? So when this condition is failed, it means we have reached a node, we have reached the node that is just before the new node which we are going to insert, that is P minus 1. So my current pointer is here. Next step is, so we are done with this. If we see these steps, we are done with this first step, that is traversing. Then what is the next step? In the next step, what I'll do is I have to make my new node point to the P minus 1 dot next node. That is P minus 1 node means this current node. right? So I have to make my new node dot next, that is this one, this new node dot next point to this. So I'll say equal to current dot next. Why current dot next? My current is over here. Current dot next means this one, right? That is 30. 20's next element is 30. Right now we have not inserted an element. Right now 20's next element is 30. So that's why I did new node dot next is current dot next. Done. Now we are done with the second step. And the third step is I have to make p minus 1 node point to the new node. I have to make this point to the new node. To make this p minus 1 node means the current node, because we will stop at p minus 1. So my current is at p minus 1. So I'll say current dot next is new node. Done. We have just inserted our element at this position, and there are some edge cases to be considered. We'll discuss them. I'll write the edge case also. I'll traverse I'll traverse until my current not equals to null. So why this condition is, let us say the value of p, the position where I want to insert is given as, let us say it is given as 100. It is given as 100, but right now in my linked list I only have 4 elements. If it is 100, if we see this logic, if I, let's say I don't have this one, I don't have this condition. So if you see this logic, it'll just keep on traversing, right? So until I reach 100 minus 1, that is 99. Until I reach 99, it'll just keep on traversing. But we don't have those many elements, right? So at any point in time, if my current node becomes null, I have to stop. If my current node becomes null, I have to stop. And if current node is null, what we can say is that position which is given is invalid. Current node will become null only when the position which we want to insert is an invalid position. Let's say 100 is given, it is an invalid position, right? In those cases my current node will become null. In those cases my current node will become null. That is one edge case. We'll write that condition again. So this is the main logic. Now let's code this. I'll write over here public void insert at position. We will be given the data and the position. I'll call it as p, the position p. Now first thing, while inserting an element we have to create a new node, right? I'll create a new node. My new node equal to new node data. I've created a new node. Done. There are some edge cases. Now let's discuss. Let's say the position is given as 0 or negative. So that's invalid, right? So if p is less than or equal to 0, then I'll simply say invalid position, invalid position, and I'll return. Done. This is one edge case covered. And let's say my position is given as 1. The position where I have to insert is given as 1. 1 means what? First element, right? We already know how to insert at start. So why to write the logic again? I'll simply call my existing function. Insert at start, I'll pass the data, return. Done. This is not an edge case, but we are cleverly handling this. Instead of writing the code again, I'll just call the insert at start function, which we already have. Done. 1 means at the first position, right? We have handled that. Now I'll take my current position, that is current position initially at 1, and my current pointer initially pointing to head. Now I'll take a while loop. Let's traverse current equals to current dot next. I'll also increment the current position. Done. And the condition is until we reach the position, that is p minus 1 position, that is p minus 1, and the edge case, current should not be null, right? At any point in time, if current becomes null, it's will just stop traversing because it's an invalid position, right? So at any point in time, if my current becomes null, it's an invalid position. So I'll say system.println invalid position again. Position. I'll return. Done. Now we have covered all the edge cases. Now we are going to insert the element. What we have to do, we have to make my new node point to the node that is next to p minus 1, which is current.next. Done. Now I have to make my current node point to the new node. Now we made a connection and we have inserted the element. Now let's see the code. Let's run this. Okay, I have, okay, let me insert one more. Okay, let me run this. Okay, where is that 42? 42. Done. Clear. So this is my linked list right now. I have 4 elements. Now I want to insert a new element, that is 50. List dot insert at position 50 at second position. At second position. At second position means just after 10. Okay, I've inserted that. Now let's display. Okay, let me run it again. Okay, simple. Now if we see, initially we have inserted 4 elements, 10, 20, 30 and 40. Next I am trying to insert an element, that is 50 at a second position. Second position is just after 10. So if we see, 50 got inserted at this. Now let's try giving some invalid positions. Let me say 200. It says invalid position and my state of linked list is the same. And let me try with 0. It says invalid position and my state of linked list remains the same. If I give 1, let's see. So now it was 10, 20, 30 and 40. I've inserted first position, it is 50, 10, 20, 30, 40. So this is how we insert an element at a specific position. That's it for this video, and in the next video we're going to discuss how to delete an element at a specific position, at a given position. The logic for that will also be almost the same as insert at particular position. There are some changes to be made. We'll discuss in the next video. Thanks for watching the video. If you like this, consider hitting the like button and subscribe my channel. Thank you.